All right, welcome. Today, we're diving into something that I bet you felt, but you just couldn't quite put your finger on it. That weird, kind of exhausting quality you get from so much of the digital audio in our lives. We're going to explore a whole new way to measure sound that focuses less on the machine and more on our own minds. Let's get right into it.
So, have you ever been listening to a text to speech voice or maybe an AI soundtrack, and after a while you just feel tired? And you can't really explain why, right? There's nothing obviously wrong with it, but it just drains you? Well, that feeling points to a massive blind spot in how we've been designing audio tech for years.
And that right there gets to the heart of the problem. For decades, the entire goal of audio engineering was something called fidelity, just making a perfect bit-for-bit copy of a sound. And we got really, really good at it. But in that whole race for technical perfection, we completely forgot to ask a simple but crucial question. How does all this technically perfect sound actually make our brains feel?
Okay, so let's get into the hidden cost of all this sound. Because this little oversight, it isn't just some small detail. The source material for this calls it a systemic risk. Our old ways of measuring sound have this hidden cost, and we've ended up building our entire digital soundscape on a potentially harmful foundation.
So here's where the real gap is in how we measure things. You know, all those classic metrics, total harmonic distortion, dynamic range, they're awesome if you want to know how a speaker is performing. But they are completely useless when it comes to measuring the impact on a listener's brain. They can't answer the single most important engineering question. At what exact point does it sound start causing fatigue? And that means for years, we've basically been guessing, building this entire universe of AI audio on nothing more than intuition. So, okay, how do we actually fix this? Well, the solution calls for a totally new way to score audio quality. And it's a really fundamental shift in how we think about the whole thing. And this is it, the Acoustic Coherence Index, or ICI. Now, this is not just another spec you're going to see on the side of a box. This is a whole new philosophy. The goal here isn't just to measure sound. It's to measure and then actively reduce the cognitive load, that mental fatigue, that a sound can cause. And you can really see the massive shift in focus right here. The old way, what's called mimetic fidelity, was all about making a perfect copy. It was about engineering for the microphone. The new way, cognitive ergonomics, is about engineering for the human brain. It's a move from asking, is it accurate, to asking something much more important, much more human. Is it comfortable? Okay, so how does this thing actually work under the hood? Well, the science behind the ICA, it boils down this idea of brain-friendly sound into two key measurable parts.
Think of this first one as a kind of energy stress test for sound. It's called E-fission, or energy stability. It basically measures how much you can crank up the volume and pump energy into a sound before its internal structure starts to just fall apart and distort. So a higher score here means the sound itself is just fundamentally more stable.
All right, and the second piece of the puzzle is T-delta, or temporal stability. This is like a timing stress test. It measures how much you can mess with the timing of a signal, with things like echo or delay, before our brain stops hearing it as one single coherent sound and starts hearing it as, well, a bunch of jumbled separate events. A higher score here means the sound is much more robust against that kind of chaos. Now, this all sounds fantastic in theory, right? But does it actually hold up in the real world? Well, the answer is a big yes. And the power of the ICA was validated in this really cool double-blind study that used something incredibly simple to prove its point.
Okay, this is where it gets really, really interesting, because all the data points in the same direction. Researchers tested two super simple tones, 432 Hz and 440 Hz. And look at this. The 432 Hz tone was physically more stable, almost 13% higher on that energy stability score. It was also temporally more robust by over 14%. And now for the big one. Listeners actually reported 21.5% less cognitive fatigue. It all lines up perfectly.
But let's zero in on that cognitive result for a second, because that's the whole ballgame right there. That 21.5% reduction in fatigue is a huge number. The tone that was physically more stable, more coherent, directly led to an experience that was significantly less tiring for people. This is the smoking gun, a direct, measurable link between a sound's physical integrity and our own mental energy. So here's the absolute key takeaway. The physical properties of a sound wave, they aren't just abstract numbers for engineers to argue about. A more stable, more coherent sound directly and measurably reduces the cognitive load on our brains. It's not about what you prefer to hear, it's about objective, measurable ergonomics for your brain.
Okay, so we've got this validated index that measures cognitive comfort. That's huge. But what do we actually do with it? Well, now we can look at the roadmap for actually engineering a better, less exhausting digital world.
And what's great is that the roadmap for putting this into practice is super straightforward. Step 1, you benchmark. You measure your current AI audio to just see where you stand. Step 2, you integrate. You build the ICS score right into the AI's training loop, basically teaching the AI to prefer making sounds that are more coherent and brain-friendly. And finally, step 3, you validate. You prove that higher ICS scores actually lead to better real-world results, like people staying engaged and listening longer.
And you can see why this matters so much from a strategic point of view. In a world that is just flooded with AI content, the company that can provide a verifiably less fatiguing, more comfortable user experience has a massive competitive advantage. It's about building trust. And beyond that, it lines up with where the entire tech world is already heading, with big standards bodies like the IEEE and even regulators like the EU starting to look seriously at the bioacoustic impact of AI. And all of this brings us to one final powerful thought. We've officially moved past the question of if we can measure the cognitive impact of sound. The science is there. The tools are there. The real question now is a strategic one. Now that we can engineer audio for the human brain, are we actually willing to do it? It's a question that's going to define the sound of our entire future.